Hey guys, Miss Miklos here, and in this lesson we're going to be talking about our sum and difference formulas, which are actually things that you guys learned last year in Algebra 2. And basically what the sum and difference formulas allow us to do is find the exact value of trigonometric functions of angles that can be expressed as the sum or difference of two special angles. So there are three different formulas that we're working with. We have sine of alpha plus or minus beta, and our sine one goes sine, cosine, cosine, sine. And I know it sounds dumb, but it is really helpful if you guys say these out loud to each other because it really just cements it in your head. So notice sine starts with sine, so it goes sine, cosine, cosine, sine. Our cosine one of alpha plus or minus beta, and just to kind of let you know, alpha and beta represent special angles. It goes cosine, cosine, sine, sine. And our sine in the middle is the opposite. So that means if my angles are added here, I'm going to have subtraction. If they're subtracted, I'm going to be added. Plus or minus means the same. So if I have addition, I'm going to have addition. So let's just kind of say these together. You can say them out loud wherever you're watching this. Sine is sine, cosine, cosine, sine. Cosine goes cosine, cosine, sine, sine. And now we move on to tangent, which is the most fun to say, but unfortunately my least favorite to do. And tangent of alpha plus or minus beta goes tan plus or minus tan over 1 minus plus tan, tan. So it goes tan, tan, 1 tan, tan. So tan is tan, tan, 1 tan, tan. So let's say all three of these together. Sine is sine, cosine, cosine, sine. Cosine is cosine, cosine, sine, sine. And tan is tan, tan, 1 tan, tan. So these are the three formulas that you guys need to have memorized for today's lesson. And I would advise saying them out loud. I'd advise writing them down every single time until you have them completely memorized. Now, speaking of memorization, the other thing that we really need to remember are our two special angles that we learned last chapter. And these were our two special triangles. You guys should have these memorized in some sort of way. Last chapter, we talked about 3 different ways to memorize them. The triangles, knowing my 9 trig function values, or using our unit circle. Okay, so we're going to be using these in our lesson. Example number 1 says find the exact value, and then it actually tells us that 75 degrees is 30 plus 45. Now, the reason why this helps me out is because if I'm finding an exact value, I know I cannot use my calculator, and I have no clue how to find the cosine of 75 in any other way. So I'm going to write cosine of 30 plus 45, and our cosine value went cosine, cosine, sine, sine. And our operation was the opposite because it was minus plus. So I have cosine, cosine, minus sine, sine. Now what we really have here are 4 different trig functions in one problem. So that's why it's important I know these triangles really well. So let's do this one by one. Cosine of 30 would be adjacent over hypotenuse. So I'm going to write radical 3 over 2. Cosine of 45 would be 1 over radical 2, or in this case, radical 2 over 2. Sine of 30 degrees is going to be 1 over 2. And cosine of 45 degrees, sine of 45 degrees is 1 over radical 2, which is radical 2 over 2. And I know that in our previous lesson, we kind of talked about the fact that we could leave things not simplified like as a rational value, like 1 over radical 2 was okay. But in this problem, where I'm looking at this, I want to simplify it as much as I can. So I should not have a radical in our denominator. So now I'm going to multiply, and I know when I multiply radicals together, I just multiply those values. So I get radical 6 over 4 minus radical 2 over 4. Here we have a common denominator, so I can combine, and my answer becomes radical 6 minus radical 2 over 4. So really our 3 steps in this problem: knowing our formula, knowing what each of these 4 trig functions was equal to, and then just knowing how to simplify a problem like this. Okay, number 2, this time we are working in radians, and it tells me that sine of pi over 12 is like pi over 3 minus pi over 4. So my sine value goes sine, cosine, cosine, sine. My operation in between is the same, so since we had subtraction, I am going to put subtraction. So once again, I have 4 trig functions I should know. Sine of pi over 3 is radical 3 over 2. Cosine of pi over 4 is radical 2 over 2. Now, I realize I'm coming up with those extremely quickly. You might need to do a little bit more work depending on your level of comfort with these. You might have to draw out your triangles every time. You might have to convert into degrees to figure it out. Okay, and that's fine, but regardless, I should end up with these as my answers. Cosine of pi over 3 is going to be 1/2, and sine of pi over 4 is going to be radical 2 over 2. So I get radical 6 over 4 minus radical 2 over 4, which is equal to radical 6 minus radical 2 over 4. So I want to point out that the 2 answers that we got here are actually exactly the same, and what we will see is that every single answer we deal with has a radical 6 and a radical 2. Now, they might be added, subtracted, any combination of those things over 4. And the reason that happens is because of the ratios we get when we multiply these trig functions together. Okay, so our third example, we have a tan one here that's going on, and it's telling us that tan is equal to 60 plus 45. Now, notice that all the ones that we've done all dealt with angles that were in quadrant 1. Sometimes we will have to deal with angles that are not in quadrant 1, and when that's the case, we need to pay attention to if those values should be positive or negative depending on what quadrant they are in. So I know tan goes tan, tan, 1, tan, tan. And in the numerator, we have the same sign. In the denominator, we have the opposite. I know that tan of 60 degrees is radical 3. Tan of 45 is 1. So I get 1 minus radical 3 times 1, which is really radical 3 plus 1 over 1 minus radical 3. Now, we know that this cannot be our final answer because I have a radical in our denominator. So we've learned that I need to multiply by the conjugate when I'm dealing with values like this. So I'm going to multiply both sides of our fraction by 1 plus radical 3. Remember, the conjugate means I have the same 2 terms. I just change the sign in between. So when I FOIL, I get radical 3 plus 1 plus radical 3 over 1 plus radical 3 minus radical 3 minus 3. So I'm going to add my like terms together. I get 4 plus 2 radical 3 over negative 2, which becomes negative 2 minus radical 3. So once again, okay, kind of my key steps in a problem like this, if I kind of zoom out here, is going to be for me to know this formula, know all of these trig functions, and then understand how to use the math to evaluate. Okay, so a lot of your problems are going to look like that tonight. The other concept we're going to be learning is going to deal with working backwards. So we need to figure out what sum and difference formula is being used, either sine, cosine, or tangent, and then we need to convert it back into the form on the left-hand side of the formula and determine what the original angle is. Okay, so example number 4 says cosine, cosine, sine, sine. I know cosine, cosine, sine, sine is our cosine value. Okay, that's our cosine formula. And remember, we saw in our formulas that this first trig function always signaled what formula it actually was. 25 and 35 are our two angles, and I know that I need to do the opposite of whatever is inside there because cosine had that minus plus. So I get cosine of 60 degrees. At this point, I need to look and see, is there anything that I can actually do to simplify this further? And I know 60 degrees is a special angle, and in fact, the cosine of 60 degrees is 1/2. So my answer here is going to be 1/2. So example 5 here, we have that same direction, so I'm going to look at this and determine, do I think this is using sine, cosine, or tangent? And I definitely think it's using tangent. And I notice that my two angles being used are 195 and 59 degrees. Since there's subtraction, I know that in the numerator we have the same sign, so I'm going to go ahead and subtract. And I end up getting tangent of 135 degrees. And just kind of to recap how we would do a problem like this, I know 135 is in quadrant 2, and it is 45 degrees away from the x-axis. So my values, my opposite would be 1, my adjacent would be -1, and my hypotenuse would be radical 2. So if I'm doing tangent, I would do opposite over adjacent, and I would get -1 as my final answer. Okay, so this is just a good recap on what you guys learned not only last chapter, but last year in Algebra 2, where we need to know those 3 formulas. So just to recap, sine is sine, cosine, cosine, sine. Cosine is cosine, cosine, sine, sine. And tan is tan, tan, 1 tan, tan. So we need to know those formulas. I also need to know our special angles and how to find those ratios.